Now, to continue our discussion of numerical integration, we want to talk about Simpson's rule. And Simpson's rule approximates by using short stretches of the curve with parabolas. Okay, so we estimate the area using parabolas. Remember the trapezoidal rule, of course we use trapezoids, and we looked at using rectangles, but Simpson's rule uses parabolas. Now here's the formula to approximate the integral from a to b of f of x d of x. Notice you've got delta x again, which is the length of your interval divided by n. Okay. The difference here, of course, between this and the trapezoidal rule, this is a 3, but then notice how it goes. Your endpoints, and then it goes 4, 2, 4, 2, 4, 2, and they alternate between 4s and 2s in the middle. Okay? Now let's apply this to the integral from 0 to 2 of 5x to the 4th dx. Okay, so first off, let's find delta x. Delta x is 2 minus 0, divided by, and we want n to be 4, so that's 2/4, or 1/2. Okay, so each one of our intervals is going to be 1/2 long. So I go 0, then we've got 1/2, and then we've got 1, and we've got 3/2, and finally we get to 2. And those are our 4 partitions we're looking at there. Okay? Now to use Simpson's rule, we take our delta x, which is 1/2, and we divide it by 3. And then what we do is we plug in 0 into our function, so that's 5 times 0 to the 4th. Okay, so that's our first one. Plus, we do 4 times our next interior point here, which is 1/2, so that's 5 times 1/2 squared. Plus, now the next one we do 2 times 5 times 1, oh, this shouldn't be squared, this should be 4th. I'm sorry, I've made a mistake there. That should be 4th. 5 times 1 to the 4th. And then we alternate back to 4. 4 times 5 times 3/2 to the 4th. Plus, and when you get to the end, when you get to the other endpoint of 2, you just do 5 times 2 to the 4th. Okay, now multiply top and bottom here by 2, and that's going to give us 1/6. Now let's think about this one. 0 to the 4th is 0. We know that's just going to be 0, so we don't really need to concern ourselves with that one. This is going to be 4 times 5. 1/2 to the 4th is going to be 1/16. 1 to the 4th is 1, 2 to the 4th is 16. Plus, we'll have 2 times 5 times 1 to the 4th is 1, plus 4 times 5 times 3 to the 4th is 81, and 2 to the 4th is 16, plus 5 times 2 to the 4th, and 2 to the 4th is 16, so we've got 5 times 16. So this is 1/6, and 4 goes into 4 one time and into 16 4 times, so that's 5/4. Plus 5 times 1 is 5, times 2 is 10, plus 4 goes into 16 4 times, so it's 5 times 81 is 405 over 4, plus, and 5 times 16 is 80. Okay, now just use your calculator. You're going to get here 32 and 1/12. So the estimate here, if you do all of the arithmetic, is 32 and 1/12. Now let's actually find that integral. Okay, so this was an estimate. Let's find what that actual integral is from 0 to 2 of 5x to the 4th dx. Using the fundamental theorem of calculus, remember that was going to be x to the 5th. If I take its derivative, that'll be 5x to the 4th. And I want to do that between 0 and 2. That means I'm going to do 2 to the 5th minus 0 to the 5th. 2 to the 5th is 32. 0 to the 5th is 0. And so my actual integral is 32. So I'm only off there by 1/12. Okay, so again, you get a very close approximation using Simpson's rule, even if n is as small as 4.